Good afternoon, students. How are you doing today?
Good afternoon, sir. I'm fine.
Doing good, sir.
Good job.
Good
Good.
afternoon, sir. I'm good.
Nice, nice, nice. What about the others? I want to hear from the others. How want to do?
Doing well, sir.
Good, good, Terry.
Good, sir.
I'm hungry, but I'm fine.
Creepy. Do you agree with me, Miss Hamilton? Amelia, was that you who said that you're hungry a while ago?
No, sir.
Who said I'm hungry?
Me, sir.
Tan.
Yes, sir.
Creepy.
No, I don't know. No.
Oh, you don't know?
No.
All right, the teacher does trouble in here. All right, so my system was up ready for you at 5:30, and then I'm trying to open your notes for class, and it was taking like about 15 minutes to open. So I decided to shut down the system, and it took a while. And then I was using another system that just kept going around, and nothing was seemingly happening. So the computer moving much faster, it needed to shut down. All right, so that's why I am just coming back in, but I was here from earlier. Word experience a serious problem. The blood of Jesus is against it. All right, so. Okay, I don't know what you're talking about. Experience. All right, so you guys would have gotten the note from me to see that the new sign-in mechanism. Hope it didn't put the document cover serious errors that centers working with the right experience. And that we are ready to go. We are ready to go. All right. So for those of you who, let me hear from you. How many of you have been going through the recordings? Whether or not you're in class, are you going through the recordings? Are you going through the handouts that I posted in the group? Are you going on Edicosoft? Some of you, you all got access to Edicosoft this week. Anybody has been on?
Yes,
Yes,
sir.
sir.
For
Yes,
the
sir.
first, yes, sir.
Very nice. Some of you are yet to sign on. I will take some time today in class.
Sir,
Yes, please.
this is my first class, sir. Or you get into Edicosoft.
Oh no, your first class. Who are you? Let me see. What's your name, sir?
Matthew.
Oh, La Forest. Okay, all right. This was a teacher who spoke with you outside. So your first class, but I know who you are. All right. Yes, sir. You have your access to Edicosoft, La Forest. Matthew. Just check your email because I remember putting you on.
All right, sir.
No problem. All
Good
right.
afternoon, sir.
Afternoon.
I did not receive an email.
Oh.
This is my second class.
I was about to say it, but I didn't want it to come off away. So I was like asking the Lord how to say it because I was going to say to you that you almost look new. But all right, I'm happy. So Tuesday of this week was Monday was your first class, right? Patterson?
Last week, Friday.
Okay, all right. Do me a favor. Just remind me towards the end of the class, or when I'm going on Edico, because I'm going to go on Edico today, so I can give you your access to it.
Okay, will do.
I was expecting this call from you, yes, sir. All right. What was I doing? Okay. Straight open the document. Document 1. Oh, keeping a jump shot. Hold on there. I'm not saving. What is happening? Alright, hold on, guys. All right, so I need to hear from you though. How many of you have been going through the recordings that I post after classes on a Monday and a Friday? I need to hear from you.
They're not the recordings, just the PowerPoint.
Or you just go through the PDF document.
Same, sir.
I went through the recording.
All right. The conversations is a little disjointed. I need to know who is talking to me. Don't see, because I don't know what this is. All right, talk again now. You're saying that you went through what?
So I went through the recording for Monday.
Okay, and how was it? Are you understanding what was done? Didn't hear you.
Oh, sir, I said yes.
Oh, sorry. Kimoli, you are very low. Are you hearing me well? Are you hearing me loud, guys?
Yes,
Right.
sir.
Okay,
Yes,
Kimoli,
sir.
you're low, Kimoli, so you need to adjust your system so that I can hear you much clearer. All right, so why I asked the question is I don't want anyone to, yeah. Quite a number of you have not subscribed to the YouTube channel, so you won't know when the recordings are placed there. So which is why I asked you to subscribe so that as soon as I put a recording that is relevant to you, that you'll be able to see what is happening. But I have been looking out, and I think maybe just one or two have subscribed. But if you don't want to subscribe, just remember that at the end of each class, as soon as the recording becomes available, I am going to put the recording into the YouTube channel. It is important. I don't understand some students. When we have town hall meetings, oh, and I've been asking for the recordings and I'm not getting the recordings. No, that if you have a teacher that gives you the recording, then the teacher has to be begging you to go through the recordings. All right. So the flip side of it is true that you believe that you're understanding, so you don't necessarily need to go through the recording. All right. But you also go through the PowerPoint, not the PowerPoint, the PDF document that I send you at the end of each class also. Whatever works for you is fine by me. All I want to know and be assured of is that you guys are understanding, you guys are learning. I don't want anybody to be left behind in class. I don't want anybody at all to be left behind. So last class we went through, matter of fact, let me just check on something. What did we do last class?
Laws of
Logarithm.
logarithms.
Okay, so log to the base a of b plus log to the base a of c equals?
Log ABC.
If I take away your lunch, money, see?
Log to the base A of BC.
Thank you very much, please. And don't let me have to take away your lunch money, Very good. Excellent. So when we add logs, we end up multiplying. Very good. And log to the base a, log to the base a of b equals?
Log to the base a, b, the power of n.
Very nice. Excellent. A equals b to the c power. A equals b to the c power in logarithmic form is? Hello?
Log to the base.
Somebody didn't study that
Of
one.
C equal A.
A is equals to b raised to the c power. From the index form to the logarithmic form is?
Sir, that would be log.
Right, you're very low, whoever is speaking.
So log B
Log to
A
the base A of
Somebody talk to me. Anybody, somebody, anybody.
Sir log B
Square log to the base
A
of
equals C.
of C equal A.
All right, Kimoli, say it again, honey bunches.
Sir log B log to the base B A.
Oh, sorry. Maybe it's my device or is it yours, Kimoli? I'm not. I know that you're
Sir, I
speaking.
don't know. I'm hearing you loud. I don't
No, but I no. Maybe it's your device because guess what? I'm seeing the microphone moving, so I know you're speaking, but I'm not here. I don't know if anybody else was hearing you, but I wasn't. Anybody else was hearing her?
I was hearing her.
Yes,
Okay.
sir.
All right. Go again, Kimmy.
Not right now.
Sir, I said log to the base B of A equals C.
Is she correct?
Yes, sir.
Log to the base B of. Log to the base B of what?
A equals C.
Equals C.
Very good. You know what sir did a while ago? Tell me what sir did. Anybody can figure out?
Quiz you.
Can I switch it up? I call the base B this time. But I'm happy that Miss Kimmy was very alert and did not get caught, among others.
That why I asked them.
A is equals to B raised to the C power, converted from the index form to the logarithmic form. Thanks, Shan, for answering. And if needs be, Shan, you can just repost the YouTube link so that those who are joining, Matthew and Miss Patterson. Is it Enia Patterson?
Enya, sir.
Enya, okay, Miss Enya. All right. Log to the base A of B minus log to the base A of C equals?
Log to the base A, B divided by C.
Very nice. I'm loving it. I'm loving it when my students are learning. And anybody remember us doing these questions last week? I mean, was it last week or Tuesday? Did we do these questions on Tuesday?
So you told us to do that.
Okay. How far have you gotten in answering those questions?
We're finished.
I'm finished.
Very nice. Woo! This is beautiful. Now, let me ask a question, and I want you to be honest. Is there anyone in the class that had forgotten about this homework, this 1.4?
Sir, I have.
Yes, sir.
Yes, sir.
Yes, sir.
Is it how much of the students forget though, Jesus? Me sure some ever eat a nice lunch money morning now because I will shake out in the lunch money. All right. So what I'm going to be doing tonight, I forgive you. I forgive you. What we're going to be doing tonight, and interestingly, let me just say something, and this is just a general comment. When I do give work, I really want you guys to take the time out and do the work. Just like the others, I really want you to take the time out to do the work, and I'm going to tell you why. So that when I come to class like a night like tonight, I don't have to be waiting for you to be doing the work in class, but I can build on areas that are seemingly problematic. So for example, when I go through question 1, if everybody is okay with question 1, I don't need to spend time on question 1, but if question 2 becomes a challenge, then no, we can have more time working on question 2 than to be working on question 1 and question 2. All right, so in future, when I do give you work to do, I'm going to ask that you really spend the time to do the work. It's not because I don't have anything else to do or I want to put you under pressure, but remember now, we have a plan, and the plan is to get our distinction here in our integrated math. All right, so let me ask the question. Log 3 plus log 4, answer equals?
Log to the base 10 of 12.
Log to the base 10 of 12.
Okay, so press pause. I heard three
So
different
whenever
answers. I heard three different answers. I'm coming to you. I'm coming to you, dearest. I heard three different answers. I heard 12, I heard log 12, and I heard log to the base 10 of 12. Which is correct? Which is /r is correct?
Log to the base 10 of 12.
Okay. Everybody agrees that log to the base 10 of 12 is correct?
all of them is the same
Yes,
thing.
sir.
Yes, sir.
Is there anyone out of the three is also correct?
Sir,
Log
log
12, log 12.
log
Log 12 is
12.
correct. So is 12 correct?
No, sir.
No,
No,
sir.
sir.
Yeah, 12 can't write. So we have to be very careful. Very, very careful. Now let me tell you how CXC is. They are very cheeky. They are very cheeky and ooh.
Sir,
Javier, can you say something, Javier?
No, sir.
Go ahead. Oh no, I was saying to you that your background was a little fuzzy. No, let me just tell you how CXC is. Very cheeky. So CXC knows the errors that students normally make. And if that were a multiple choice question, trust me, all of the following are correct except, and then put 12, log to the base 10 of 12, log 12. But some students will select all of the above. They have to be very careful of just using a jargon. And this is why on Tuesday, on Monday, I don't know what I'm talking about Tuesday. On Monday, I'm asking for people to verbalize for me what it is that you're doing. And I want you to verbalize. So it's very important that you speak to me on the thing. So when Javier, for argument's sake, can say to me, 1 + 1 is 2. It means, and she tells me the operations involved. It says to me that I know she's following exactly what is happening. And I need to know. All right. So very good. So log 3 + log 4 is going to be equals to log 12, or log to the base 10 of 12. Remember, guys, when we're not seeing a base, we assume what number?
10, base 10.
Very good. Can we assume any other number but 10?
No, sir.
No,
No, we can't. We can't. You can't say, you know what, I'm going to choose log to the base 5. It's different. So log 3 is not the same answer as log to the base 5 of 3. Log 3 is the same answer as log to the base 10 of 3. And we would have gone through this before. So I'm just going to say to you, and Matthew and Enya, all the recordings, there are 3 recordings in the channel for integrated math. I'm going to ask you to go through. Join those classes asynchronously. Go through the areas that you're having difficulties with. You can highlight them to me on Monday when next we meet.
Yes, sir.
Yeah, cool.
Yeah.
So it's very, yes, Matthew.
Which topic address log alone? We finish.
I'm not yet finished with it, but yeah. So we are only in logarithm and exponents. Yeah. So we started unit 4 in module 1. So this is the first thing that we are doing. But I would have gotten to quite a bit. Tonight, what I want to do is to go into some equations, and then completing the equations, Matthew will complete the topic on logarithms and exponents. But you will be able to follow. Just go through. There are 3 recordings that I've placed in here so far. Just go through them. If you're not following, just link me and let me know. There's also a WhatsApp group for those who are joining. And I know I have very responsible students here that I don't even have to ask or say anything further. I know you'll be added shortly, Matthew. So they will tell you what to do. All right. No problem, Pop-up. All right. Log 6 minus log 2. The answer is?
log 3.
Log
Log
3.
3.
Very nice. And why is it log 3? Somebody verbalize it for me. Why is it log 3?
Log 6 divided by 2.
Aha. All right. Is Kimoli correct?
Yes, sir.
Yes, sir.
No. Kim says a while ago log 6 divided by. Was that what you said, Kimmy?
Yes.
No. Is it log?
It would
6?
be the log. It would be the log of base 10 is 6 divided by 2.
Very good. Very good. So this is why, class, I want you to speak to me so that I can hear what is in your head space, so that I can say to you, no, you're right or wrong. Because I know Kimmy got the answer enough. Without a shadow of a doubt, I know she got the correct answer. Kimmy, what you got for your answer? Log 3?
3.
Yeah, man. So I know she get the right answer. But what I want her to do is to be able to verbalize the correct procedure. So when you can speak the math, any question the man give you, you shell it because you know what it is. All right. So it's not going to be log 6 divided by log 2 or log 6 divided by 2. It is going to be log 6 over 2 or log to the base 10 of 6 divided by 2. When we subtract logs, we divide. When we add logs, we multiply. Log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. Sir, my first class in me area taught some gibberish I don't know about. You can say it again. Sit here. We derived a few laws last week, and we are now using those laws. Log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. When we're adding logs, we end up multiplying. When we're adding logs, we end up multiplying. So log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. Whenever we are multiplying, whenever we are adding logs, we multiply. Whenever we are multiplying logs, we add. Let me tell you how CXC can give you the question. I was saying, you know, them people that cannot cheat. Let me tell you how they can do the question. They can give you a logarithm that is already combined and ask you to separate it. And you say two something or multiply each other. So you may say 15. You may say log 15. How could you break up log 15? All right. Let me just start that something here because log 3 plus 1. Oh no. Okay. Come on, computer. All right, how do you think we do that? So I'm asking to write. I'm asking to write log 15 as a single logarithm. How would you do that? Write log 15 as a single, as a single. Right, log 15 as 2 plus e to the power t. Then, all right, so I'm asking to write log 15 as two separate logarithms. How would you go about doing something like that? Write log 15 as two separate logarithms. Can anybody give me a suggestion?
Log 3 plus log 5.
Easy 1, 2, 3. Very good. Easy 1, 2, 3. Easy 1, 2, 3.
Sir, you could say log 30 minus log 2.
Yes, so nice. Is she correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Any other suggestion? Can we go anywhere else? Talk to me. What about log
Sir, log
45?
60 minus
Log 60 minus who?
4.
Minus 4. Very good. Very good. Excellent. 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 So what it is that we have done here, you're given log 15, which is really log to the base 10 of 15 as two separate logarithms. So you can write it as log 3 plus log 5. Why, sir? Because log to the base a of b plus log to the base a of c means that you multiply the two numbers. It's going to be log to the base a of b times c. So 3 times 5 is 15. But when I subtract my logs, I'm dividing, and 30 divided by 2 is 15, so I still get my log 15. So anybody who writes this in the exam gets the same number of marks as this, and there are so many others that we can do. So many others that we can do. All right? We can say log 15 plus log 1. Is that correct?
Yes, sir.
Yeah, man.
Yes.
So it is just manipulating the laws that we would have done. Oh Lord, where are they? Right. Just manipulating the laws that we would have done right here. Log to the base a of b minus log to the base a of c is equal to log to the base a of b over c. And I'm giving you these exercises as they come up, just like when I would have been in a face-to-face class and ideas come to my head, I'll just put something on the board. It doesn't make a difference if I am in an online class. I can do the very same thing. So it's very good to know that you guys are alert. Now, for those of you who are wondering how them did get that, we're going back to the law. The law says log to the base a of b minus log to the base a of c is equivalent to log to the base a of b over c. So when someone says log 30 minus log 2, it means that because I'm subtracting, I'm going to be dividing. So it's going to be 30 divided by 2 is 15. All right. So you can go ahead and you can do as many of these questions as you possibly can, because once it is that you understand the laws. Now, let me tell you, I wrote this question this way from my headspace just now, but what they normally do in the exam is to give you a multiplicity of these things. Okay, let me try write one of them. Hopefully it can work for the copy. So paste, right, that's your classwork. Start that for me, please, as a single logarithm. As a single logarithm. So this is how they normally ask you to do this stuff.
Sir?
Yes, please.
Sir, how about log 5 minus log 9 plus log 27 to give
For the
15?
For the first one?
No, yes, sir, to give
All right.
15.
No, hold on. You go too fast, man. Because you know what you just do a while ago. You say you now left out of the equation, so you go find one. Come, say it again, honey. Now. Log who?
Log 5 minus log 9 plus log 27.
9 plus log 27. All right. Before we move on to the other one, I just want to just check this one. And what should I do first? Okay, let me check this one, because this one is going to help you for this one, the one that I just wrote. So log. Let me just write here. Give me half a second, please. Set up another device. Another second. Very nice though. Who just conceptualized this question? I need to get the voices.
Gordon.
Oh, Tan. All right. Very good, Taniel. You are thinking outside the box, and that's what I'm expecting of you, my student. Let me create all right, let me just do something quickly to the side,
There's
right?
one more.
There's one more. All right, let me hear that other one.
They're half log 25.
Sorry. Undo. Let me go again.
They're half
Log half.
log. They're half log 225.
All right. Somebody can help me out what she said. Kimmy, you know that I don't know if this is you don't want to talk to me tonight, but I really am having a difficulty. I know, no, you keep secret. I say no. It's just like what you said a while ago. I'm talking now. Talk like that every time. Half log who?
Half log 225.
That's it. A half log 25. All right.
Yes.
All right. We're going to check on that one. No problem. I'm writing it. All right. So let us go with let me put an S here because there are many solutions to that. So let us go with log 5 now. So we're going to write log 5. We're going to write log 5. So we're going to have log 5 minus log 9 plus log 27. All right. Now, when we're subtracting logs, what do we do again?
Divide.
So this is going to be log 5 over 9 plus log 27. When we're adding logs, what do we do again?
Multiply.
It's going to be log 5 over 9 multiplied by 27 over 1. 9 into 7 goes 1 time. 9 into 27 goes 3 times. And 3 times that equals?
15.
So therefore we have, this is going to be log 15, which is also correct. Very good. Log 15 is correct. Excellent. So let us look now at the other one, a half log 25. Now, which?
Sir,
Yes, sir.
She said 225.
Oh, you see me. Tell us, I'm not here, Kimmy. You know. Thank you very much, here, Kimmy. I keep secret. Kimmy. Sure. Kimmy, I keep secret to our teacher. You know, we don't like that, you know. All right, 275. Thanks, please. 275. 275. Kimmy, you do chemistry?
Sir,
Kimmy?
I said 225.
CMT. All right. So me here 25. Your classmates heard 75. So you know, say you're not speaking up. Kimmy, you do chemistry, honey?
Yes, sir.
Yeah, man, you're tired. I know you just had class. You're tired. That's why. Never mind. Sorry. What am I looking for?
No, sir.
You're not tired? No, but your classmates.
Sir, I didn't have chemistry.
Oh, okay. Or is by you have a 3 to 5? Which one?
Environmental science.
Oh, all right. All right. So she said 225. 225. 225. All right. Which law? Because I don't know where Kim get this from, you know. I mean, I have a clue where Kim get this from. I don't know where on earth Kim is going to pick up this question from, because I don't know which law to use. She see everybody give 2 different logs. Look at the first one. The first one is log 3 plus log 5. Then you have log 30 minus log 2. Then somebody said log 5 minus log 9 plus log 27. She no come give one something. The question can work with one something. Can the question work with one something, guys? Talk to me.
I know that you said 2 separate logarithms, you know. I was just hearing.
No. Kimmy, come to my business. Leave me alone. I'm building up on something, Kimmy. Leave me alone. Me soon come back to you. Can I do this? She see everybody else have 2, and then one person get 3, and she decides to give 1. Which law do I use for this one? Is there a law that we can use for that?
So bring it up
Yes,
and
sir.
Tell me what to write.
You would you would raise the 225 to a half.
There's a law that says that?
No, sir, I don't know, but if you work it out, you get an answer. You get
Yes,
15.
sir.
There's a law. Tell me the law, no man. I don't know. Where the law go?
sir some power law, I remember it.
Sir, N,
It start with N.
N,
And what?
N log A,
Log to the
N
base A.
log to the base A, B, raised
Equals
to N,
equals
equals
Log to the base A
log
of B
the
N.
log to the
very good. Kimmy, I'm proud of you again by a bag of tigers. You see, Kimmy, jeez, I'm on bag juice, no cows bag juice.
Sir, I cannot eat tigers. Tigers have been flour.
So what you want? Lobster?
Sir, I don't eat lobster.
What you want? Is that me? No, is that? Look at my kiss got in. Very nice. Very nice, Kimmy. No, I was only trying to see if others would have agreed with me when I said that there's no law, but clearly you guys are learning. Kimmy, this is very good thinking, and trust me, I'm going to give you an extra % for the next test, for the first test you get in. And 1 extra % for coming up with this. All right. But we not finish it, do you know? Because can I write 225 as something with a base and a power? Tell me, can I write 225 with something as a base and a power? Can I find the square? What is the square root of 225?
15.
Very good. So it's going to be 15 squares. And the law that says a to the m raised to the nth power is equal to a to the mn. The law, recall, a to the m raised to the nth power is equal to a to the mn. All right. So with that law, what we can now say is that this is going to be a log of 15, because 2 times a half is a whole. So I'm going to have log 15. Very, very, very good. Excellent. Very, very good. Very nice. Lovely. Lovely. And what that says to me, Kimmy, is you have an understanding and an appreciation of the laws of logarithms that we went through. And that's very, 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 very good. And I really want the rest of you to get to that stage. So we look at it and we recognize that the possible solutions, let me just put possible solutions here, as there are many, and I mean, there are many people, SSI, SSIDLE. There are many solutions that we can come up with here. Many more solutions, right? And I am particularly pleased with that one, a half log 225. Particularly pleased. Very, very, very good. All right. So for the rest of you who are still wondering how it is that we got to where we got to, which is why I decided to write on screen so that you can see what it is that we have done. I want you to get to a point where it is that you can have a greater appreciation of the laws. Trust me. Trust me. These laws are going to come back to haunt us sometime later. For those of you who are doing Unit 1 math, and for the Unit 2 math, it's going to come back at some point in time. When we would have gone through these questions, and I may not even go through all the questions, because when we're supposed to do the homework, I'm going to go through as many of them, and then we're going to be doing, I found 2 past paper questions on what it is that we have done, and I just want to drop them in the class, because remember, as we go along, we're supposed to be working these past papers, because when time comes for our exam, our final exam, easy 1, 2, 3. When we go into the exam laughing and then come out laughing. right? Easy 1, 2, 3. So that's very good. Excellent. Excellent, guys. Big up on yourself. Now, I'm asking you, I just wrote this out of my head and I'm asking you, can you write this as a single logarithm? Anybody has completed it?
Yes, sir.
And what is the answer?
Log to the base 10 of 15 over 8.
All right, so let me just write that. I'll try to find a nice color. Let me find the best color around town. You said log to the base 10 of
15 over 8.
But you can't have a logarithm like that. Can you? You can't have a logarithm. You're supposed to have a logarithm with a whole number alone. You can't have a logarithm with a fraction. Hello, somebody.
Yes, sir.
You think you can have a logarithm like that? Log to the base 10 of 15 over 8? That like it makes
Yes.
sense?
Yes, sir.
Yes, sir.
Why? Why not?
No. It just look like a wrong answer.
Sir, we did not learn anything that says otherwise.
Who teach you?
Sir, you never teach us that we can have a log like that.
Okay, but the laws that I would have gone through tell us that come out to the final answer, don't? Yeah, no,
Yeah.
talk to me now. All right. Okay. All right. So if you hear me talk like this, I don't want anybody to start getting nervous to say, geez, I'm gonna do something wrong. I don't know. I have not yet done it. I just wrote it. But I'm asking you the question because I want you to think. I'm not going to say to anybody that you are right or you're wrong, because you need to be given an opportunity to think about it. All right. Now, walk me through the stages. What do I have to do first? I want somebody to walk me through the stages. Look at what teacher did. What teacher did here was to use the same law that Kimmy just told us about. 2 log 4 is the same thing as log 4 squared. Talk truth.
Yes, sir.
Yes, sir.
Very nice. And then now, I am going to now do my stuff in stages and say, you know what? I'm not going to jump in the gun. I'm going to write this in such a way that those who are not following can see what I'm doing. All right, look at this. So what I did here was to say, do the first part here, so to say, log 2 plus log 3 to give me log 2 times 3. Anybody agree with that?
Yes, sir.
All right.
Yes, sir.
Very nice. And then my other step is going to be log, oopsie daisy. Look at that and tell me if you agree with that. Somebody.
Yes, sir.
Yes, sir.
Very nice. When you must talk to me, you know, we get really put energy when we hear back from one, you know. Real talk. Enough energy we get. All right. And then now, all right, so that's exactly what it is that I now have up top there. And then I'm going to just do a little thing where I'm going to just try to work out that. So 2 times 3 is going to be 6, and 4 squares is going to be 16. And then now 16 times 5 is, sorry, 6 times 5 is 30. So I'm going to end up with, copy. I'm going to end up with 30 over 16, which is going to give me 15/8 log 15/8. 15/8. Let me see if that's what we were told. Log 15/8. Whoa. Right. Very good. No, that's not what I want. I want that. And I want to do that. Very good. Excellent. So that's exactly what it looks like. Very, very, very nice. A question like this on your exam is about 4 or 5 marks. About 4 or 5 marks, right? So just follow what teacher did. What teacher did was to go step by step. See all the steps here that we do? All the steps here that we do? We know when we're adding logs, we'll multiply. We know when you subtract logs, you divide. And again, adding logs, you multiply. So you know what I did? I didn't even evaluate none of these. I just carry the steps. I carry all the steps and show you. And when I got to this last time, 2 times 3 is 6, and 4, 4, 16 times 5, and 6 times 5 is 30 over 16, which is going to be equal. 2 is common to the numerator and denominator, so I'm going to get 15/8. But sir, you never put to the base 10. That's fine. Everybody knows that is going to be log to the base 10. Talk truth.
Yes, sir.
Yeah,
Yes,
man.
sir.
Very
Sir,
nice.
so why you never group it and then you subtract it?
I never group it.
Yes.
I could. Okay. Let me talk about that. You group it and subtract it and got the same answer.
No.
You got a different answer.
Yes, sir.
All right. Because you see that term here. So you say log 4 squares is not log 4 squares. It's a negative log 4 squares. So what I don't want anybody to do is to rearrange the logarithms and get it. So you can't say this times this plus that, and work out the sum as NG, because this negative log to the 4. Go ahead.
Sir, I group it and get it.
You group it and get it?
Yes, sir.
All right. So look at what is happening. Look at the point I'm making here. You can't just work this out as say log 4 squares, because this term here is not log 4 squares. It is actually negative log 4 squares. No, if you're grouping it this way to say log 2 plus log 3 plus log 5 minus log 4, what we're going to have is going to be log 2 times 3 times 5, and 5 times 3 is 15, 15 times 3 is 30, divided by 16, 30 divided by 16. So if you group it that way, yes, you'll get the same answer. You have to be careful. Who said I group it and didn't get the correct and didn't get that
That's
answer?
not how I did it. I did it log 2 plus log 3 minus log 4 squared plus log 5. So it would give you a log 6 minus log 60.
See?
Yes.
No man, 4 squares is not 4 squares
80
is
I
not
mean, 80 I mean.
by 80.
Yes.
Aha! That's
Yes.
the point that's the point I'm making, That's the point I just making up on the bunches. All right, mute for me because your television is loud. All right, press pause. I'm happy that you made that error, and I'm going to tell you why I'm happy you made the error, because I want to talk about it. No, listen to what who was that a while ago? I need to get the names. Who was that a while ago?
Me, sir.
Okay,
Aniki.
Heinz. Aniki. All right, I'm happy that you said that, Aniki. And guess what? And this is why I want you to talk. Listen to the mistake that Aniki made. Aniki says 4 squares is 16. So log 16 plus log 5 is going to be log 16 times 5, which is log 80. But that is not correct, because this log is not log 16. It's a negative log 16 that we have. So she can't say 2 times 3 is 6 divided by 80. That's what he did, right, Aniki?
Yes, sir.
Right. So that is not allowed. So whenever you have whenever you see a negative log, you have to be careful. You have to say Mr. Negative log. You can't just call it negative log. Your name is not same size. When you see the positive ones, you can't call it, hey, log 5, come here. But when you see a negative log 4 squares, Mr. Negative log 4 squares, can you come here, please? You have to be very careful. So don't make that error again. Please, please, please do not make that error. You can't say log 4 squares plus log 5 squares. That's not what we have. the sign in front of that 4 squares, that log 4 squares is a negative sign. So it tells us that we can't do it like that. So which is why the other student who says that, sir, but I grouped and I got the same answer, would have gotten that answer because the person grouped all the positive ones together first and then dealt with the negative one after. So you have to be very careful. No, having taught this, for quite a while, over the years, I often say to students, nobody rearrange, nobody trouble the something with them give. Work it like what it is. So if the negative sign they come right here, so put the 2 over the something. It's like what do man something here, so and you just and then you work it out the last piece on here, so just do it like that. Right? A question like this comes to about 4 or 5 marks. We don't want to give it those 4 or 5 marks. We want them. We want them. We're having what 3 questions, 3 sections, modules 1, 2, 3, and each module gives us 2 questions. Each question at 25 marks. So 50, 100, 150. Yeah, man, we have to get about, we have to get at least 125 out of the 150. Right? Because we're getting our distinction for the course. So we don't want to lose any marks for that. So Aniki, I'm happy. Thank you very much for making that mistake. And guess what? You are going to write something in the book that I will not make this mistake again so that you can see it. All right. Very good. Very good, guys. Is there anyone in the class that is not following what is happening? Talk to me. Is there anyone in the class that is not understanding what is happening? Matthew, you say a while ago, for the addition to the WhatsApp group, or you saw something a while ago on screen. Which one?
No, no, the screen, so as a long time reply.
Okay, all right, cool. All right. Now, like last week, when I stopped the class because I was calling upon individuals, because I know that when I have a class of 23 students and I ask a question, are you following? That there are students in the class that are not following, but refuse in the face-to-face class to say, sir, I'm not following. And worse is online, when again say it's not following. But so sir, again call him not. Don't you know that, right? So I want John Mark. This one is yours. I would love for you, John Mark, to give me the answer for number 3. What answer you got for number 3, John Mark?
Oh, so I didn't do the exercise. So I can do it now and come back to you.
Okay, you can go ahead. Go ahead and start working on them, please. All right. Kisana, Green. Kisana, what you got for the answer, hon? Number 3. We soon call upon you. Just on you quickly, please.
Sir?
What you got for number 3?
Sir, I
This
didn't
one.
do it.
You didn't do it. All right, no problem. All right. Well, no problem for tonight. Kesiano, what to get?
Sir got log 3.
She got log 3. Is there anyone in the class agreeing with Kesiano that she got log 3?
Yes, sir.
Yes, sir.
All right, let me just check my answer here, and I will come back and do something quickly with you. Log 3 is correct. Very good. Log 3 is correct. All right. Natalie. Natalie, what you got for number 4?
Sir, for which number?
Number 4. Numero 4.
Sir, I got log 18.
Log 18, that's one right. Is she correct?
Yes, sir.
Yes, sir. Yes, sir.
Very good. You are correct. Buckley,
Sir, can you do that one, please?
I am going to. After Buckley, okay. Okay, so you just answered number 5. Okay, I have to leave number 6 now because number 6 has a trick to it. All right, so let me go to what number it says that was again. Oh Lord Jesus! All right, I don't have it. I don't have it in this document. All right, hold on a minute, please. Let me see if I can find that. I had worked it out for you, in preparation for class, but give me half a second, please. Half a second, coming up. Solutions. In the interim, did anybody do number 6 and got an answer?
Yes.
All right. Kimoli, I soon come to you, because if you get this right,
Yes, sir.
very nice. I can give back the lunch money that I take away from you. Lord help me. Hold on a minute, please. Money. All right. Where do I put this now, Lord? I'm going to put this. I'm going to put it right here. All right. So you were questioning the one on. Sorry, which one were you asking me to do now? Forgive me. I lost my track. Log 4. That's number 5. You were asking me to do
question 4.
Question 4. 2 log 3 plus log 2. Question 4. 2 log 3 plus log 2.
Sir, never mind. Never mind.
I
I didn't write off something properly. That's why I didn't get the answer.
Okay, I'm happy that you said that now.
For number 2.
Anybody else want me to work number 4? Are you
Yes,
okay?
sir, me.
All right, no problem.
Yeah.
Thanks for your honesty. Log 4, okay, so I didn't do log 4, but let me go through log 4 with you now. So remember, 2 log 3 is the same thing as what? 2 log 3 is the same thing as?
Log 3 to the second power.
Very good. Log 3 to the second power. Very good. And log 3 to the second power is the same thing as?
Log 9.
Excellent. Very nice. And then now log 9 plus log 2 is the same thing as?
Log 9 times 2.
Excellent. 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 And 2 times 9 equals?
18, log 18.
Very nice. All right, so just look at what it is that we have. So 2 log 3 plus log 2, we have the law that says log to the base a of b to the n is equal to n log to the base a of b. So I'm going to take this 2 as a power. So it's going to be log 3 squares, which is what I have here. And I just simply wrote back my log 2 and then log 3. Sorry, 3 squares is 9. And so I'm going to have log 9 plus log 2. When I'm adding my logs, I multiply C to so 9 times 2, and then I get log 18 as my final answer. All right, so that's question number 4. Question 5 says a half log 4 minus log 6. I'm doing the same rule that I did right here. This is going to be log 4 raised to the half power. So it's log 4 to the half. But guess what? The minus 6 is constant because I can't break that up. But 4 I can break up to be 2 squares. Now there's a law that says a to the m raised to the nth power is going to be equal to a to the mn. A to the m raised to the nth power is going to be equal to a to the mn. So I'm multiplying this 2 by this half, 1 half, and 2 halves make a whole. So I'm going to have 2 to the first power. Let me just change this and just put that 1 there so at least you can see that what I'm talking about. It's 2 to the first power. All right. So having that 2 to the first power there in blue, I am subtracting. So therefore, and I'm in the same base. Remember now, when you're doing the question, and I'm emphasizing that because there's a question I have there where the question is not in the same base. So it must be in the same base in order for you to be applying these laws. So here are the laws again. Log to the base a of b plus log to the base a of c is going to be equal to log to the base a of b times c. Log to the base a of b minus log to the base a of c is going to be equals to log to the base a of b over c. Log to the base a of b to the n is going to be equals to n log to the base a of b. So we're in the same logs. We're in the same logs. So if I give you a question, log to the base a of b plus log to the base c of d plus, I mean, you have to do something very special with that one because we're in different logs. So it must be in the same logs in order for me to apply these logs. And as I said before, you don't know which of the laws will come. You may use one law, and then after that, no, case in point, we use one law right here, so to get this, then we're going to use another law here in order to get that. So this question has 2 laws. In doing this question, we're doing the first law here, then this one have a second law right here, so we're using 2 laws, no, and then the subtraction, so we use 3 laws right here. Matter of fact, we use all the laws right here, so, right? So you can get a question where you end up having to use all the laws. What's the point I'm making? You can't say you understand this law, but you don't understand another law. You have to learn and understand and appreciate all the laws because you don't know which of the laws will come for the question. So a half log to 4 is going to be 4 to the half. This is going to be 4 is the same thing as 2 squares. 2 halves make a whole, which is why I have this one. And log 2 minus log 6. I'm in log of the same base, and I'm subtracting, so it's going to be 2 over 6. So it's going to be 2 sixths, and 2 sixths is the same thing as 1/3. So I'm going to get log to the base 10 of 1/3, or just simply log 1/3 in the question. Are we okay so far?
Yes, sir.
Good job. All right, and I'm going to stop the class again.
Wait, so you can go over that one, please?
And I thank you very much for your honesty. Who was that? Natalia. Okay, thank you, honey bunches. I thank you for that. And I'm going to come, Natalia. Come in, please. 1 minute, honey bunches. I don't know what else to say to some of you. Because me know, because of your silence, that you're not following what is happening. And I don't want, along with those who are following, for us alone to be having the fun. Because it is really a Friday evening little jam that we're having. It's just that we don't have no music. I want them 2 nights so we can have a little music or 2. And whoever can dance, then push with the decks and bust a little one tune and then we'll come back to class. Because class is supposed to be fun. Maths class is supposed to be fun. And if you know me well, or anybody who I've taught in the past, we carry domino come maths class and we lick 2 domino and we make 2 knives and we say, all right, come, maths time again. All right, because maths is supposed to be fun. We're supposed to enjoy our time in class. But I'm particularly concerned about those of you who are silent. Your silence is deafening. So Natalia, I big you up for not seeing something and say to me, sir, go it over. All right, so I'm doing this for Natalia, and I'm also doing it for those of you who are not understanding but are very silent. So let's go again. So this is a question. The question is a half log 4 minus log 6. Now recall, n log to the base a of b is equals to log to the base a of b raised to the n power. See here? N log to the base a of b is equals to log to the base a of b raised to the n. So what I'm saying to you is that this n that is outside here, I can rewrite my logarithm and put this n as a power. So it becomes now log to the base a. That does not change. That is constant. See here, log to the base a and log to the base a. The only change now happens with the function, not the logarithm, but with the function. And this function is b. What I can say is b to the n. So that's what I'm using. That's the law that I'm using, Natalia. So I am going to now end up with log 4 raised to the 1/2 power. Log 4 raised to the 1/2 power minus log 6. You know that this log 6 is the same log 6 as I have here because I really have not done anything or trouble it. All right? The only conversion that I'm doing is this. Okay. But I recognize that 4 can be written as 2 squares. Just like what Kimmy says, 225 raised to the half. But 225 could be written as 15 squares. Then, sir, how you know so the power going to be 2? Remember, sir said to you, generally just look at the denominator right here. So it doesn't always work, but generally, because we give you questions that are solvable, chances are this 2 down here, so is something that can be written with a power 2. And just think outside the box. 4 is the same thing as 2 squares. So I'm converting my 4 to 2 squares, and then the law that says a to the m raised to the nth power is equal to a to the mn. I'm multiplying the powers. When I have a base raised to a power, which in turn is raised to another power, I multiply both powers. So 2 halves equals a whole. See right here, so? That's why I have this one right here. So I'm going to have 2 to the first power. You notice my minus log 6, minus log 6, minus log 6, minus log 6 is the same constant. Don't trouble him at all. Big boss run here. Pitbull, right? So let's go. When I'm subtracting my logs, I divide. So it's going to be log of 2 divided by 6. See it right here, sir? Log 2 over 6 here. Not log 2 divided by log 6, you know. It's log 2 over 6. And then, of course, I'm going to break it down into simplified. 2 into itself 1, 2 into 6 was 3 times. So I'm going to have 1/3. And this is what it works out to be. Log 1/3. Any clearer, Natalia?
Yes, sir.
Good job. Is there any other questions so far? All right. So go ahead.
Like the log kind of mixed me up for this one, the logarithm.
But for this one here that we just did?
In. Like I'm understanding it without the laws.
Wait a second. You understand the question without the laws?
Yes, because when you were explaining about the n equal log a.
Oh, okay. I guess what you're saying. So when I speak about the laws of logarithm, it confuses you?
Yeah, with the a and the b and the something. Yes.
Yeah, so what I'm doing is just a general form. So you have to, let me just warn you. Let me not just you alone, Kessie, is it Kessie? Let me not talk about you just now, but let me just prepare some of you who will end up going to the university to do mathematics. I'm not scaring anybody, but I'm just going to tell you. So what we're doing right here now is math. You see unit 1, unit 2, applied math, integrated math, further math, mechanics and probability. It's just math. You see, when you go to the university, it's going to be a different level of math that you're seeing. So you see the same thing I'm talking about? In the abstract form, it almost looks English. So I'm preparing you, Tess, to get into the habit of learning the general form and then translating it into more specific forms. So I hear what you're saying. I too was like that, and until I went to university and then got the shock of my life. So I am now preparing my students to not to get the shock of their lives and be able to, vacillate from one to the next. So what she's saying is that, sir, when you speak in a general form like log to the base A of B plus log to the base A of C is equal to log to the base A of B over C. Sir, I can't be like that. But we know, sir, that once it's something at the same log and you multiply, you just multiply the two functions then. It's the same thing, but I'm giving you in a general form. So, okay, but if that's what it is that you're saying to me, then I know that you're understanding. Any other questions before I move on? All right. So I did ask a question. If anyone did question number 6, and I heard somebody say yes, who was that?
Yes, sir.
Okay, Kimmy.
Yes, sir.
All right.
I did it too.
Nice. Anybody else?
I did it, sir.
Yes,
Very
sir.
nice. All right. So, Tanil, I'm choosing you out of all of them. Tanil, you represent everybody who said them do it, Tantan. So make sure you get the right answer. Now, Tantan, what you got for the answer for number 6? Tanil, not talking again. Kasana, you said that you did it. Come, what you got for the answer for number 6?
Log 5.
What you say?
Log 5.
Log 5. All right, hold that. Kimoli, what you got for the answer?
Log 4.
Log 4. Blow account to account. All right. Who else did it? Yes, please.
Sir,
I
I'm
get
just
log
hearing
4.
what you say now, sir.
All right, I'll come into you, Tanil. Shani, Chanel, tell me what you said.
Sir, I get log 4.
You get log 4. All right, so 2 log 4, 1 log 5. All right, Tanil, what you got?
Sir, I got log 50.
Log 50. All right, okay. So let me just pause and just speak on another matter. So as these matters come up, I need to talk about them. You see, the important thing, John Mark, is not for you to do the question and get them right. It's for you to do the question, make an attempt, and when sir goes through this question now, you can see where it is that you would have gone wrong, so you can learn from this experience. All right. So with that said, sir is not interested in a correct answer, but I want somebody to explain to me this 2 minus 2 log 5. Outline the steps for me, please. Tell me what it is that I must do in order to get my answer. Anybody, somebody.
First, you have to write 2 in a log form.
I have to write 2 in a log form. Very nice, Kimoli. Kimoli, may really struggle to hear, I have to put on my glasses to hear you pretty well. You're correct there. How do I write 2 in a logarithmic form, Kimoli? What do I write?
Because we're working with base 10,
Mm-hmm.
log 10 is 1, and 2 times 1 is 2. So 2 in a log form is 2 log 10. Or could rearrange it.
So we get 2. So we get 2 log 10. And then when I rearrange it, I can get log what?
10
Mm-hmm.
squared.
And then I'm going equals to log what?
100.
Very good. Very good. Excellent, honey bunches. Excellent. All right. So I have a question for you. She did it a little differently than how I have done it, but I'm going to explain what it is that I have done here. Now, remember what it is that we did in these questions up top here. When we're doing those questions, and I said to you, I'm going to let X be my unknown, and we're going to evaluate all of those stuff. It's the same something we're doing. We're not change it. We're keeping the same course. Where am I right here? So look at what it is that we're doing. So I recognize that these two things are of a different form. So I can't have apples and expect to subtract bananas from it. I can't get an answer. I can have apples and subtract apples from it. I can't even have American apples and subtract the Jamaican apples because there are two different types of apples. So if I say apple minus apple, sir, are they the same apples? All right. So I must get this too in a form that looks like this. Sir, what do you mean? This is in log to the base 10. This is a whole number. So I need to convert this whole number in log to the base 10. So I'm going to let x be the unknown. So because I know I want it to be in log to the base 10, I'm going to say log to the base 10 of a number must be equal to this too. So just like what Kimoli says, I'm then now going to be writing this from the logarithmic form to the index form. So this now becomes 10 squares is equals to x, and 10 squares is equals to 100. So x here is going to be equals to 100. So what we are saying is log to the base 10 of 100 is equals to 2. What Kimoli says, sir, log 10 is 1. Log to the base 10 of 10 is 1. So that means, 2 log to the base 10 of 10 is going to be 100. Same difference. All right. So now what we're going to have is log 100. Oh dear, you saw me bright? Never finish the question enough. Log 100 minus 2 log 5. Log 100 minus 2 log 5. See here, log 100 minus 2 log 5. So this now is going to be sorry, before I do that, I'm going to do something else. I didn't do the conversion here, so forgive me. Let me just do the conversion here. No, the conversion is here. So now that I write it in the same, both of them in the same log, I'm going to apply the law. This is going to be log. I'm doing this because I don't want anybody not to follow what it is that I'm doing. It's going to become 5 squares. Matthew, are you following, Papa?
Yes, sir, I'm there.
Good, good, good. Anyhow, or you stay?
Yes, sir, I'm following.
Very nice. All right. So I'm using the law to say log 5 squares, and which is this, and 5 squares is 25. And then now I'm going to do this conversion. And this is going to give me, because I'm subtracting, it's going to be log to the base a of b minus log to the base a of c is equals to log to the base a of b over c. So this is going to become 100 over 25. And that is going to give me an answer of log 4. I think 25 divided 100 divided by 25. Yeah, log 4. All right. And that's what we got our log 4. So those of you who said log 4, you are correct. Very good. Very good. All right. Something just came to mind a while ago when Matthew answered me, and I need to stop and ask. And the reason why I'm asking the question is not, well, it is for my own benefit so that I can go and do my homework. Are you understanding when I teach online? Is this methodology working for you guys? When I type the notes like I'm doing right here, when I write, as I would have done up here, to get a quicker explanation, is there anybody in the class that is struggling to understand what it is that I'm doing? I want you to tell me as it is just now, because this is going to be for me to help you so that I can go back to the drawing board and try to do something new. How is it going so far? This is 2 weeks of classes now.
Sir, it's okay.
It's okay.
It's okay. When you can tell me if it's not okay, let me know. I need to know. Is there anyone in the class that is struggling to understand what it is that I'm doing because of when I'm working and you see this black screen comes up, every time sir doing a question, this black screen come up and it just annoy me. Well, that black screen is me using a software to type so that the word can come neatly to you, because you know everything that I do here at the end of the class, I send you a copy so you can have your notes, well organized, so it is that you can have it in an electronic format to go and work with. Is there something you want me to do differently? Is my audio okay? Am I speaking too fast? Am I teaching too fast? Am I only talking to the ones who are answering me and ignoring the others? Let me know, please. Just unmute and just talk to me. 2 more minutes. All right. Matthew, how is it so far? I mean, I know this is your first class, but for the last 1 hour, how has it been?
Good, all right, sir. Understand.
Okay. You're understanding. Very good. All right. Now, students, the sort of feedback that I ask for in my class is feedback that will cause me to go back to the drawing board to do something differently so that I can reach you guys. I know that, this is unconventional. You're doing a day program, but your math class is in the night. Sir, who learn maths at night from on Monday and from on Friday? Sir, Friday, but it is a time where it is that we're going to be coming together for the rest of the school year. So we need to get with it. That's number one. And number two, we're going to make the class very fun and very interesting. Right? There's going to come a time when it's going to be laborious. But for now, I think this is a fun part, and I want you guys to follow. So if at any point in time, you can make a suggestion to me, how I can improve the class, trust me, you will be helping me so that I can reach you better and better reach my other students. All right? So let's go. Let's continue. All right. So just remember that 2 years so can be subtracted from the log sum here because of 2 different numbers, 2 different formats. 2 different formats. One format differs from this, so we have to do something separate. Now look at this. Is this something similar to this one?
Yes, sir.
All right, very good, very good. Do me a favor. For those of you who did this and did not get log 4, I want you to look at this question. I'm going to give you 2 minutes. If you've done it before, fine. Just hold on to your answer. I'm giving you 2 minutes to look at this piece up here and kind of work the piece here, and let us see if we can get everybody getting the same answer. Okay. Sad that you have to do it. Understood. All right.
Here, where is that to?
The piece around there, so half log 9 plus 1.
How many it is, sir?
Log 18.
Huh?
What is it again?
Log 30.
Oh, log 30. All right, let's see if the others get to know. I don't think it's right though, but maybe try with the others.
Sure, I got log 30.
Yeah, maybe.
The log of base 10 is 30.
Okay, well, maybe you're not wrong together, but we don't know. We're gonna try it. The rest of you, go ahead.
So you're saying that this down here is similar to the one up there, so?
You don't think so?
No, sir.
Anybody think it's similar?
Yes, sir.
Yes, there is just different
All them use the
operation.
different sign.
Yeah, right. It's similar, man. Because you get one with 2 different something in there, you have to go to a conversion first. So yeah, man, them similar. All right, so let's go. We will see if we agree. We agree with whether or not it's the same. Ah, sir. What I see, sir, is that the questions normally come like this. Because remember, no, um, you've seen one, two, three, four laws of the logarithms. So most of the questions come will be pretty much of the same type. So this a half log 9 is going to be the same thing as log 9 raised to the half power plus 1. And 9 is the same thing as 3 squares. So I'm going to have log 3 squares raised to the half power. And the law that says a to the m raised to the nth power is going to be equal to a to the mn. So I'm going to be multiplying my powers to give me 3 to the first. So I have reduced this to be log 3 plus log 1. This is the same thing as this, log 3 plus log 1. But Kimoli says log to the base 10 of 10 is 1. So I'm here saying to you, 1 is log 10. And see the example above here. We're going to do the same thing. Log to the base 10 of a number equals 1. This one here down here, so we're going to have 10 to the first power equals x, converting from the logarithmic form to the index form. 10 to the first power equals x, 10 to the first power is 10. So that means x is 10. So my unknown is going to be 10. So I'm going to have log 10. So what I'm going to have is log 3 plus log 10. And when I'm adding my logs and multiplying, so I get log 30. So very good. Very, very, very good. Very good. Any question?
No, sir.
All right, good.
So I have a question, but I don't know how to ask it.
Okay, try.
Can you get everything from, because at first you said my understand come down to the 3 to the second power and the half plus the 1. And I did one in the bracket correct. But then again, after I done that, I did times it by the 1. I never know so much I do the log and a 10 something more.
Oh, you said log, you said 3 times 1?
Yes, because you just say when I add it and you multiply.
Very good. Okay, excellent. Stop right here. I'm happy that you corrected yourself. You're saying that when you're adding the multiply, but what do you multiply when you're adding Casey?
Repeat, sir.
What do you add when you're multiplying? What do you multiply when you're adding? I'm sorry.
The 3 and the 1?
No. You remember I said this is supposed to be in the same form like this, you know. Watch me. Watch me. Watch me. See it yourself? You multiply right here, so don't Cassandra.
Yes, sir.
But read this for me. Read a line here that is spotlighted. Read a line there for me.
2.
Say it again, honey.
Log 9 plus 1, log 2.
All right, hold on there now. Read a line for me now.
Log 3 plus 1.
Are the same something you read a while ago? Same format? What is different?
One of the logs is gone.
Ah, so I must put the log there. You follow what I'm saying, honey?
Yes, sir.
Let me give you an example. So, me I go foreign. I'm have me want to carry a patty and rum and them something there for my family. Eh? But through me I go foreign, I have about $1,000 to spend. You know, foreign people not give no money when they go there. They want. Them want you carry the whole of Jamaica and them not give no money. Because them put you up to a week or 2. And me say, you know what? I don't know much of the rum, I don't know much of the party, and I'm going to want gizzard, and I'm going to want bust and them something. So I'm going to carry about a $50,000 with me. I carry $10,000 bill. And when I done shopping, everything come to $25,000. So I have $25,000 left. And of course, I'm not going to leave the $25,000 in Jamaica because in my pocket. But when you go foreign now and a shopping, and my $1,000 done, me can use my $5,000 bill and pay the something up there, so Cassandra. Talk to me now.
Yes, sir.
We can use my $5,000 bill when my $1,000 run out, my 1,000 US run out, you know. We can take up my $5,000 bill and get the cashier and say, take care of this.
Mm-hmm.
I don't hear you. Yeah? No?
You hear me, sir?
I don't hear you, no, sweetie.
Yes, sir.
I'm saying to you, can I, when my money run out, we can take out the $5,000 Jamaican $5,000 bill and say, cashier, you take the money out of that?
No, sir.
Why?
I have no idea, sir.
Okay, can somebody tell her why we can't do it?
I don't think she hear when you ask everything.
Yeah, I think our internet is going in and out, right? But you're following the example, though, Shani, that I'm asking, right?
Yes, sir.
Yeah, man. So even though it's money, you know, it's the same model. It's money. The common denominator is money, but two of them are of a different form. So somebody could say, yes, sir, them can take it, you know. Okay, when them take it, what they're going to do? If they will accept that form of payment, they have to convert it. Because if I flip that to Jamaica now and say, you know, me never spend out the whole of the $1,000, but come back with $100. But me go my supermarket now with the $25,000 when me did carry up with it. And them tell me, say, my bill come to $28,000. I'm going to give them the $25,000 and them say, blow up, no more money with me. And I say, but me have $100 US. I'm say, you know what? Me can't give them the $100 US. I can give them the $100 US in Jamaica because we accept that as a form of payment. But the man will say to you, say, before I can accept it, this is a rate that we're buying it for. We're buying it for $100, 100 Jamaican dollars to $1 US. I mean, you say, you're crazy. Me not sell you again. Take off the items because we can't go run on the road and get it for $130. So me not take off two other items. We can buy them later tomorrow. So we have to make sure, the point I'm making is that we have to make sure that before we do the combinations, that both of them are in the same format. You see, log to the base A of B, log to the base A of C, both of them must be in the same format. Log to the base A of B minus log to the base A of C, they must be in the same format before I can go ahead and do anything to combine. So again, I'm happy for that error, and that's why I take a lot of time to explain the errors so that you don't make those errors again. So yes, I cannot say 3 times on history and get log 3 for my answer, because this here is not log 3, it's not 1, it's actually log to the base 10 of 10. All right, so both of them have to be in the same log. So when I convert that, I'm going to get log 10, and then now I can do the log because they both are in the same something. And again, by extension to the something, there are times you go to you go a miracle, and then you know you have a cambio. So you may be walking on the road and you say, hey, cambio, and you walk inside and they say that I have Jamaican currency. And they say, yeah, man, we accept Jamaican currency too. And then convert your 25,000 Jamaican dollars and make you 150 US dollars. So you can actually do the conversions, right? So you have to convert it. You must have the same something first. All right. So am I clear with that? Talk to me, guys. Don't go to sleep.
Yes, sir.
Very nice. Very nice. Very nice. Okay. So I reach a point where I know nobody's going to get this one. I apologize for giving you this question. I know it would have stretched some of your mental capabilities, and I apologize because I know none of you got this one correctly. Let me hear one or two of the answers that you have gotten right here.
Sir, 2.
Log 2.
Okay, so I'm hearing 2 and I'm hearing log 2. All right, who else?
Sir, I know that the answer is 2, but I don't know the log part. You get what I mean?
Shanil, unmute money.
Yes, sir.
Say it again.
The 2.
You know the answer is 2, but
Oh, it's never mind.
All right, so I'm hearing two answers. Can somebody tell me which of them is correct? I'm going to tell you that one of them is correct. Can you tell me which of them is correct? John Mark, you are not a member of my class tonight.
So they are listening, sir. I'm spectating.
Yeah, you're spectating, man. You're a big spectator today. You play left off of the field. You're not in my class tonight, John Mark. Last week you turn up, and today not turn up. You see when you don't do your homework, what happened?
So, sir, may I do the question them as we go through?
Yeah, but
after the answer.
But you're not talk to me. Tatiana, you're not talk to me tonight, neither.
So let me know the one they had, man. The one they look tricky.
Where you give the answer there, John Mark?
So I don't know how to do it.
You don't know how to do it? Okay. All right, no problem. Natalia, what you get? I hear you clear your throat like you want to tell me an answer. Tell me your answer, Natalia. Don't laugh at Natalia. Tell me your answer,
Yeah, but
Natalia.
me did not text, sir.
You see how you know Natalia boo. All right. Matthew, let me hear what you give for your answer, Papa.
Log 9 over log 3, sir. I'm not enough to do that.
You don't know if you do that one day yet. All right, no problem. All right, that's fine. Nathaniel, what do you get for your answer?
2, sir.
You get 2? I don't understand. We in a log, a pure log we are talking about.
Sir, there is log 100, but I don't know how to work it out step by step.
Listen to me. I am speaking the way I'm speaking, because I want people to develop their confidence, right? So I'm speaking the way I'm speaking. All right. Melia, you're the last person before I do the question. Melia, talk to teacher. What do you get for the answer?
You talking me?
The one yes, Amelia. You me talking to? Tell me for the answer here. Talk it now.
Sir, log 2.
Oh, you got log 2. All right. Shanti, tell me your answer again, honey bunches.
Sir, 2.
You get 2. All right.
Sir, me? Yes, sir.
Somebody said log 3. Hey, Sharifa, don't come cramp my style, not sure. You're right, though, Sharifa. You're right, man. You're right. I'm proud of you. You're right. Very nice. All right. So what Sir was doing was just trying to be mischievous. No. Hold on there. Did somebody say 3 a while ago? I was reading my chat when I thought I heard somebody say 3. Did somebody say 3 a while ago? Be honest. Don't let me play back the recording, Be honest. Did someone say 3 a while ago? Okay.
There nobody that said 3, yeah, here too.
Maybe I want to hear a 3 so I can start telling why it's not 3. All right. So since Shani, nobody never said 3, let me tell you why it couldn't be 3. It is illegal to say that you're canceling out the logs. Illegal to say canceling this log and canceling this log, and then we have 9 over 3, and then 3 into itself goes 1 time, and 3 into 9 goes 3 times. So the answer is 3. Wrong. So this here is not 3. Now, look at this magic. Look at this magic. What we're doing is converting this 9 into 3 squares. Converting this 9 into 3 squares. And when we convert 9 into 3 squares, then we're going to apply the law. Log to the base a of b to the n is equal to n log to the base a of b. So it means that, oh, come on now. It means that this 2 is going to go in front of the log. See it right here, so 2 log 3. So 2 log 3 now becomes log 9. And then because I have log 3 and log 3, I can cancel out the log 3s. So my answer is only 2. Look at that. Agree with me? Disagree with me? Let us have an argument. The answer 3 could not be because I can't get on the inside of the something and just can't see it all like that. I have to apply the laws of logarithm in working the question. I can't just go ahead and cancel out. So that don't make it. I have to do the laws of logarithms. Work it, work it, work it. 9 is the same thing as 3 squares. And then I'm going to use a law that says log to the base a of b to the n is equals to n log to the base a of b. It means that I'm taking the power and put it in front of the logarithm. So now I'm going to get 2 log to the base 10 of 3. Sir, I'm not seeing a base 10. Okay, no problem. 2 log 3. Same difference. Now I'm going to have 2 log 3 divided by log 3. And the mere fact that I'm dividing my 2 logarithms, I can cancel them out like that because there's a log 3 and a log 3 there. So I can cancel it out. And I'm going to left with 2. All right, very good. There are more than one of you who told me 2. The person who said log 2, look back at that. Can't be log 2, it has to be 2. With that said, work this one down here so for me, please. And tell me your answer. Log 125 over log 5 and tell me what you get for your answer.
Two same way, sir.
2?
Wait a lie. 3.
All right, very good. So it's going to be 3 because I'm doing the same thing like I did before. Different question, but when I say same thing, it means that it's the same procedure. 125 is the same thing as 5 to the third power. 5 times 5 is 25 times another 5 is 125. And I'm using the law, this 3 comes in front of it. And because I have a log 5 and a log 5, those log 5s can cancel out. And I'm left with 3. Very important. Very, very, very important. Everybody see that? Is there a question?
Yes, sir.
Okay, good. Matthew, you see it no, Papa?
Yes, sir.
Nice. All right. All right, so we have a few more. We're at number 10. All right, let me just not rush the process and just maybe spend some time and do this. All right, do me a favor.
Sir, we didn't do 8.
Oh, we never did 8. Oh, I'm sorry. I'm jumping the gun. What is off for number 8?
Log 20.
Log 20.
Log 20.
Log 20.
All right, let me check to see if. Let me check if I did. You never do it to me? Oh, jeez. I didn't do it. I can check my answer though. I think I have my answer up here. Number 8 is log 20. Log 20 is correct, but I didn't do the question. Let me just work the question for the sake of those who copied that one. Thanks for telling me that you haven't done it. It's going to be log 125. Okay, so all right, so copy, I'm going to paste in. All right, so this is a black box I'm telling you about.
Sir, I must do that one.
Yeah, go ahead. Sorry, I have this other screen that is coming up. I'm not talking because I want those who are working to not to be disturbed by me, so that's why you're not talking. As soon when I'm finished with this, I didn't ask. Oh, there you go. Log 20 is correct. So again, my half log 25 is the same thing as log 25 raised to the half power, which works out to be 5 squares raised to the half power, which works out to be log 5. 25 is the same thing as 5 squares. When I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying both powers. So two halves make a whole. So I'm going to end up with log 5. And 3 squares is the same thing as 9. And 6 squares is the same thing as 36. Now remember, I cannot say log 9, 9 times 36, because you see a plus sign here. So because this log 9 is a negative log 9. So be careful. You can't say 9 times 36. It's not 9 times 36. The mere fact that this says it's a log 9, it means that this is in the denominator. This portion here is in the denominator, so you have to be very careful. So look at what I did. I work in stages, log 5 minus log 9. I'm going to put log 5 over 9. And then times this now by the 36. And if you want, I can put another line in there so that you can follow even closely to what it is that I'm doing, because I really don't want anybody to be making these careless mistakes on these questions that can carry in the bulk of the marks. So that line here, I'm saying log 5 divided by 9, and then plus this 36 is going to be this piece, 5 nines, multiplied by 36 because I'm doing my addition. And the 9s cancel, the 9 into 36 goes 4 times, and 4 times 5 is 20. Or if you want to multiply 5 times 36, then you get that number divided by 9 to give you 20. All right? Any questions?
No, sir.
Am I fully clear? Thank you for that. Is there someone in the class that is not following? Is there someone in the class that is not following?
What you said, sir?
I'm just checking to see if there's anyone in the class that is not understanding what it is that I'm doing.
Oh.
Right. So very good. I'm going to be giving you a little text next week just to see that you are understanding what is happening. And let me just tell you what is going to happen. I'm going to give you an end of unit test. So on Monday, all being well, I should complete this unit. And then on Friday, I'm going to give you a little test. It may be at the start of the class. It may be in the middle of the class. It could be towards the end of the class. Just a little test, just a little something. Little 1, 2, 3. All right? Just for me to see exactly what it is that you guys are understanding. It's going to be a time test. It's not going to be like a 1-hour test. It's just a little quiz that I'm going to be giving and showing you guys how to upload your stuff to be on Edico. And at the end of each unit, I'm going to give you a unit quiz. At the end of each unit, I'm going to give you a unit quiz. So I will know those students, that are understanding, and those students that are not understanding. So I'm giving you enough time to go and do your preparations. All right. With that said, let us do what is there to be done now. All right. No, we did that one. This is where we are. Anybody got that one?
Sir, log X.
Ha ha ha. Log X. All right. Anybody else? Any other answer? Any other answer other than log X?
Sir, I got negative log to the base 10 x minus 1.
Okay, Shante. Any other answer?
So I want to log x minus 1.
Log X minus log X minus who?
1 log to the base 10 x minus 1.
X minus 1. Okay, all right. I heard a correct answer so far. Won't tell you who. And that was very good thinking. Proud of you. But you soon know who. I give you give one person another opportunity to tell me. Anybody else? One more answer. Anything else? All right. So we have to be very careful with this one. The laws of logarithms are still evident here. The laws of logarithms still work. The laws of logarithms will dictate how it is that we're doing this stuff. Now, let me just pause and say something to you. So I'm giving you the question, log x plus 1 minus log of x minus x squared minus 1. You're still using the laws of logarithms. Just follow the laws then now. And then you have some prerequisites from little school that you already know. Just use those prerequisites and twerk the question and you must get the answer. Real talk. You must get the answer. There is no two ways about it. You must get an answer. Let's go. When I'm subtracting my logs, what do I do?
Divide.
So I'm dividing. But before I did that, what I did here was just to expand my x squared minus 1 that I recall. And it's a difference of two squares. All right, that's what you need to remember. So that's a difference of two squares, and as a result of that, you now have to go and kind of fix it up. Have to go and fix it up. When fixing it up, we're going to go and expand, and when we expand that, we're going to get x minus 1 times x plus 1. X minus 1 times x plus 1. X minus 1 times x plus 1. So I'm replacing my x squared minus 1 into x minus 1 times x plus 1. So this is what I now have for my new question. And because I'm dividing, I'm subtracting my logs, I'm going to divide. They're in the same base. They are both in the same base. Both terms are in the same base. So it's going to be log x plus 1 over log x minus 1 times x plus 1, which is here. I recognize that x plus 1 in the numerator and denominator. So I'm going to be canceling. So I'm going to be left with log of 1 over x minus 1, which is the same thing as x minus 1 to the negative 1. X minus 1 to the negative 1. Copy. So recall 1 over a to the positive m, 1 over a to the positive m is going to be equals to a to the negative m. It's going to be equals to a to the negative m. So what do you mean by that? If I have 1 over a positive number, if I choose to take this number here, a to the positive m to the numerator, it now becomes a to the negative m. So I have x minus 1 in parentheses. So it means that I can't just move the x and leave the negative 1 because the x is married to the negative 1. They will not separate. So what is going to happen is that this x minus 1 is going to be taken to the numerator as a whole. So it becomes x minus 1 to the negative 1. This is a rule. We did this in the first class. This is a rule. So it becomes log x minus 1 to the negative first power. And what it is that we do, and I'm writing the laws for this one here because it's a little different from what it is that we have been doing. And I want you to see how these laws come back into it. The laws of indices, the laws of logarithms, they come back to haunt us. Copy. So I want to recall this now. I want to recall that, and by saying to you that this one here is going to be n log to the base a of b. Let me put it the other way around. I'm saying to you, log to the base a of b to the n is going to be equal to n log to the base a of b. Watch this. So this is log to the base a of b to the n minus, sorry, x minus 1 to the negative 1. I'm going to put this negative 1 in front of all of that. So I'm going to get negative log x minus 1. Shantae, this is what it told me, right, honey?
Yes, sir.
Very good, yes, very good. All right, so I'm going to project this so that you can all see this question. Right, I need to fix up this thing here. I don't know why it's like this. Okay, I think it was dragged. Oh, sorry. I'm just going to copy this and paste it right so I can fix that one. Log to the base a of b to the n is equals to n log to the base a of b. Are you okay so far? Are you seeing where I'm going? Are you following me? Are you learning? Are you not learning? I know these are a lot of questions, but you're getting out some nice good things coming out from them. All right, so let's go. Let's go. What time is it? I'm supposed to be 8:30.
I get it, sir.
Nice, good job. Good job. All right. Can we try that one, please? Have we done that one?
Yes, sir.
Yes,
I
sir.
got log to the base a of 10.
Of 10?
Yes.
Anybody else got that?
I got log 3.
No, sir.
No, sir.
Sir.
Wait.
Sir, I got 0.
I got 0.
0.
I got 0.
Yeah, man. You're so nice.
Don't do person.
You're so nice. Do me a favor. I am not going to talk yet. I'm going to give you 3 minutes. That may go up to 5 minutes to look at this and to see if you understand what it is that I'm doing. Those of you who never got 0, and then I'm sitting right here, and then I will just unmute and go through. But I want you to go through this on your own. And I'm going to tell you why I'm doing this, because I will do some questions and submit the solutions to you. And you must be able to read these solutions and understand what is happening. All right? So do that for me.
So you know, seminar wrong do based on what's in my book.
Okay, what is your final answer?
So I didn't write the 2, sir. So technically I'm not.
Let me answer a question. So you're cute. Let me answer a question. If you're gonna CXC and write on the wrong question, is he gonna get the mark?
No, but
okay. But I get the point though. You're saying that your steps that you would have written in your book would be correct, but you wrote up your answers for a different question, not the question that I have on screen. Right. Yeah, I got you. I'm just struggling. Yeah, but you have to remember though, you have to be very careful when you're transcribing the questions that we really write it off. All right, so we agree with this one?
Yes, sir.
Come on, any questions? So remember now, similar to what it is that we have always been doing for the whole night, this is in the form log to the base a of b to the n is equals to n log to the base a of b. So I'm going to write this as log to the base a of 5 squares. I'm writing back this, and I'm converting this to log to the base a of 10 squares, because I'm just applying this law, just this law. Then I am going to be saying 5 squares is 25, 10 squares is 100. So I'm just actually rewriting this line. I am not taking anything for granted. I am showing you my steps. I want you to show your steps also. These steps will award you marks in the exam. And just like what sir has always been doing, I'm not going to rearrange nothing, because this is not log to the base a of 100. This 100 is supposed to be in the denominator. Sir, how you know it's the denominator? Because I have a minus sign each up in front of its log. So we know so this is going to be the denominator. So I'm going to work it in stages. Log to the base a of 25 times 4. Why times 4, sir? Because I'm adding minus log to the base a of 100. Then no, I know that no. Now I can see that this is in the denominator. So I'm going to have all of this divided by 100. Now 25 times 4 is 100. And 100 divided by 100 is going to be equal to 1. So log to the base a of 1, log to the base a of 1 is going to be equals to 0, because anything raised to the power 0 is 1. So converting this log to the base a of 1 from the logarithmic form to the index form is going to be a to the x equals 1. No, x has to be 0, because anything raised to the power 0 is 1. So you know that this is going to be 0 for your answer. Question.
Sure. The last part. Can you explain it back like the 1 base to the power of 1, I get it to be 0 again.
No problem. Thanks for your question.
So I understand everything come down to where we have
No,
25
you don't have
times
to apologize. You don't have to apologize, Papa. You just not seen it, so I'm going to do it now. So log to the base a of 1. I'm going to let x be the unknown. So I'm going to let that be equals to x. All right. So I'm converting from the logarithmic form to the index form. It's going to become a raised to the x is equals to 1. Now, what number do I raise x to give me 1? What number, John Mark?
0, sir.
Very good. Anything raised to the power 0 is 1, and that's why that answer there is going to be 0. X can only take X can only take one value in order for it to be 0. I mean 1, and that value has to be 0. It can't be anything else. Can't be anything else. Very good. I will confess something to you. This is not what I had planned for tonight's class. I wanted to move into another form, the final form of the logarithms, into moving into some equations. I did this because Matthew is here for the first time, and Enya would have missed the first week along with Matthew. So in doing these questions, we'll sort of catch them up for the week that they weren't here for. So that's why I did what it is that I'm supposed to be doing. But come Monday though, all being well, come on Monday, I'm going to be going through the other aspect of the logarithms. Of course, that includes indices, and finish it off. So I'm going to finish off on Monday this unit or first unit of module 1, and I give a little pop quiz on Friday. If worst case scenario, if I need to spill over anything, spill over the first part of the class on Friday to finish off. But for next week though, next week I'm finishing off logarithms and exponents and start another unit. I would have sent you a copy of the syllabus, and you'll recognize in module 1, sorry, there are some longer units and there are some shorter units. Now, my aim is to go through, and I'm thinking that I want to do the longer units first so that I can get those out of the way. There's a short unit like coordinate geometry. Now, coordinate geometry is what all of you I know how to do. I'm not going to waste time. I'm going to do something like that. I'm going to be touching on a topic that I know you have not yet done, so that I can get those big guys out of the way, and then there's a small something there, and we just work on that. So chances are I may move to module 7, unit 7, before some sequence and series, so we can get some nice mathematics out of the way, and then I'll come to the, yes, Papa.
Yeah, I can breeze through coordinate geometry, just give you an idea how to go set on the paper.
Yeah, absolutely. The point I'm making, with Matthew, with the coordinate geometry, are things that you already know. The equation of a line, gradient of a line, y2 minus y1 over x2 minus x1, to find the midpoint of a line, x1 plus x2 over 2, y1 plus y2 over 2, to find the length of a line. Two lines are parallel, they share the same gradients. Lines that are perpendicular, the product of their gradients equals -1. So those are things that I know you know from CXC. And that's why I'm going to do it. But I'm just saying to you, when I start doing it, it will come back to memory. So it's not that I'm not going to be doing it, I'm saying that you have seen that topic before. My aim is to do the ones that I know you have not yet seen, so that you can have enough time to digest those, so it is that you can master those. I will teach you the short topics, the ones that you have seen before. But I'm saying the moment you see what it is, you say, oh yes, it's true, it's so this thing, here they go. All right. So I think we should be able to get to where it is that we want to go, but importantly, is that when I do give you the work, you must do it so that we can get there. All right. This one is easy. What's the answer for this one, please?
0.
Yeah, it should be the same thing as this one because 13 times 2 is 26, and 26 over 26 is going to be 1. So it's going to be the same format as this one here. All right, same format. All right. And this one, let me just go through this one because this one is really the same. No, this is the one I was talking about. I want you to do this one for me. Anybody do this one?
No, sir.
All right. No, so this is what I was saying to you. So you have to make sure that all of them are in the same base. Uh-oh, this first one is in base 5. This one is in base 3. This one is in base 2. So none of the laws of logarithms can work. There is no way you can work any of these laws of logarithms. Look at what is going to happen though. The first line, come on, the first line. Everybody knows that because I can write log to the base 5 of 5 squares. We know this. We all know this. Minus. But sure, this two not supposed to be right, so. So good things out. Look. The two they're not supposed to be that at all. The two they get used up already. The two they get used up already. And then now 2 log to the base 2 of 8 is just going to be log to the base 2 of 8 squares, right? And I think my third line, nope. All right, so now that we have that there, I want you to evaluate this. I want you to evaluate log to the base 5 of 5 squares. Then I want you to evaluate log to the base 3 of 27. And then I want you to evaluate log to the base 2 of negative 8. So you're going to evaluate these independently, not as a whole, like we have been doing. Why, sir, not as a whole? Because they are in different bases. Every one of them is in a different base. So evaluate what log to the base 5 of 5 squares is. If you want, I could do this and do that and say log to the base 5 of 25 and 8864. If I want, I can do that and say work out these individually and tell me what to get, please. I don't want to do it, I want you to do it. Start, please.
Sir.
Yes, please.
When I say evaluate, I mean get the answer. Oh.
Anybody finish?
Yes, sir.
What you
Yes,
got for the
sir.
answer?
So I got one.
Okay.
-1.
Negative.
-1 is correct. Very good. Thank you for the correction. Thank you for the correction. -1. So I actually had that line, so let me remove it. And again, I'm going to let X be my unknowns. I'm working them out individually. Matthew, you asked a question. You weren't here when we did this format. So log to the base 5 of 25 is equal to X, the unknown. And I'm converting from the logarithmic form to the index form. So it becomes 5 raised to the X power equals 25, which is this line. And I'm writing this 25 into 5 squares. And since the bases are the same, I'm going to be equating the powers.
Sir,
Please. Go ahead, son.
like we convert the log them to numbers and work it out. Could I do the other question with the log and the number?
No, the other questions, if you look at the other questions, this one, the base was unknown. So
No, not that one, sir. Like the one we did earlier with the 2 minus 2 log sum.
Which one? 2 minus 2. Right, this one here, 2 minus
Yes,
2 log
sir.
5. Yeah, no, because no, because in this case, what it is that we're trying to do, if the instruction for these ones here is we're writing as a single log. Remember, that's what we're doing, All of these questions here we're writing as a single log. This one is an evaluation. We're evaluating number 13, number 14, and number 15. You will see me write number 15. Number 15, you see I have something here that the question is really determine the value of X that makes all of this equals to 2. And that's a K 2009 question. So the question is, I am actually evaluating all of these here. This one, the others here, I'm writing as a single log. So you notice, with the exception of this one, this single log here, the answer is 0, so I put it as 0. But all the other questions here are being evaluated as
Also, that's the other one was simplifying them.
right. And then this one here, no. And what you need to remember again, that these ones will have an unknown, so I couldn't get a final answer, right? But these ones here, I'm actually writing as a single log. I think that's where I had started when I talk about single logarithms right here. So that's where I'm going. Fair enough?
Yes, sir.
All right, cool. Yes, so this one here now we're evaluating, right? Evaluate. We're evaluating all of that. All right, and then the final one. I'm saying we need to determine, and I think I'll just use this to end the class. Determine the value of X that makes log to the base A of 4 plus log to the base A of X minus log to the base A of 7 equals 2. And that's a CAPE 2009 question. So again, Matthew, this is not really to get an answer, because I said I have some unknowns in there, but I want to get a value of X. What should X be in order for all of this to work out to be 2, which is what I'm asking. So go ahead and write that for me, please. Remember, follow the laws. first check to see if you're in log to the base, if you're in the same base for all the logs. If that's a yes, then you can use the law of logarithms, the laws of logarithms. If they are not in the same base, you can't use the laws, you have to go solve them individually. Right? Continue.
Sir, the answer for that question is just 2 and not log to the base A2.
Right. So I want you to find the value of x that makes this answer, when you evaluate it, to be equal to 2. So it means your answer, so I want the value of this x. That's what I want to find. The value of this x. So of course, the term is going to be in log to the base a still. You follow what I'm saying?
Yes, I'm following, but I was wondering if you do this equation, it must equal to just 2 alone, is not log to the base A of 2.
No, it's going to equal to 2 alone. Dege 2.
Okay.
It's like when we evaluated the one of Chris and we get dege 0. Yeah, man, we may dege 2. Sorry. I'm showing my answer. All right, I give you another 3 minutes or so. And then we look at it and then we can close off class for tonight. Where am I? Come on. Wait. Yeah, here you go.
Sir,
Yes, Matthew.
for example, suppose you have log base A or fraction equal to a number. Where you gonna work out that?
That's fine because I mean you're just working on the value of x. I mean, yeah, you're just working on I know what it is that yourself and John Mark asking. So when you get your value of x, it's going to be in the form of log to the base a. That's the only hint I'm going to give to you. It's going to be in the form of log to the base a. Does that help in any way, shape, or form?
I really say what me some can do.
All right, then cool.
Sir, can it be a whole number and a decimal?
A whole number and a decimal at the same time?
Yeah.
Give me your answer as a fraction. Put it in fractional form.
So I got 7/2.
You got 7/2. Who is this? Who got 7/2?
Gordon.
Okay. All right. This is 22 minutes past. So look at what it is that I have. The question here says, all of this. You know that when you are adding your logarithms, the first thing that you're going to be doing is to check to see if you're in the same base. And you're in the same base, so now you can combine the logs. So it's going to be log to the base a of 4 times x to give you 4x minus log to the base a of 7, and that is supposed to be equal to 2. So the left-hand side is supposed to be equal to the right-hand side. But when I'm subtracting my logs, I'm going to divide. So it's going to be log to the base a of 4x over 7 equals 2. All right? Now what I'm going to be doing, I'm going to convert this from the logarithmic form to the index form. So it's going to be a squared is equal to 4x over 7. And when I multiply both sides by 7, I'm going to get 4x on this side and 7a on this side, 7a squared on that side. So here I'm multiplying multiplying both sides by 7. Why? To get rid of this 7 right here. And then I'm going to have 7a squared is equal to 4x. And I divide both sides by 7, by 4, because I want x. I'm going to get 7a squared over 4. And then x is going to be equal to all of that. Look at that and tell me if you agree. So that's the value of x. X has to be 7/4 a squared. And I'm going to give you that for homework to prove your answer. So you're going to go back to the question and you're going to prove your answer. All right, I'm going to end here. Oh, no feel. Any questions?
No questions, sir.
Sorry. I just saw the chat, but guess what? I'm sure you are fine now that I've explained it. All right, I'm just seeing those questions. All right, no problem. All right, guys. As per usual, I'm gonna send off the document here for you. For those of you who just joined, I do send out the document that I work with in class um, to the WhatsApp group, so that you must get into the WhatsApp group in order to access the documents. And so every class that I use a paper, the document, I will be sending you. When I say to you that I'm finished with Unit 4, I can say to you that, I'm going to print the document because I finished with it. We now go back to the document again. All right, but don't print yet. For those of you who have access to printer, don't print it because I'm going to be adding more information to the document. So that's what I'm trying to do for you now, is to go through the other preparations of the other areas of the syllabus. So I'll just write some questions and do the solutions and write the explanations. And as I'm teaching, I'll put more questions in there and develop the document, so the document becomes much more useful. Outside of that, you should be fine. Importantly, go through, prepare. So those of you who are coming for the first time, this document will include everything that we would have been using from last week. So you don't have to ask around for the previous documents, because this document now supersedes all the other documents that would have been circulated. Any final questions before we say good night?
Yes, sir. Where did a squared equal 4x over 7? Where the a squared come from, sir?
Oh, I'm converting from here, from the logarithmic form to the index form. Remember, I'm solving for x. I'm solving for x. I need to get rid of that. So I have to convert from the logarithm to the index to give me this, right? To give me a squared is equal to 4x over 7. And then I multiply both sides by 7 to get rid of that. I'm trying to isolate the x. So I have to go through all those steps. All right, so this is where we are. Think about it. Watch me. I am at page 23 out of 31 pages so far. So those 8 pages is a one class something. And I can show you, this is what I want to do. Some calculations, further calculations. If I don't finish this by Monday, I'll go to some other, by Friday for sure, we'll go to that. So I'll be finished with this one and then start off with the other for you. So you can have the information to prepare. Please, I don't want anybody to get my handouts and make dust gather on it. Use it. It takes a long time for me to prepare. My preparation time for you guys. Last weekend, Saturday and Sunday, I had to say to myself, it's time to go to bed because I haven't done a whole lot of preparations for you. Now, the only way you can show me appreciation of the amount of work that I'm putting in is for you to digest the information, so it is that you can use it to get your distinction. If you get a grade 2, we don't want that. A distinction, no want. All right? Bless your heart. Gentle Jesus, meek and mild. Have a good night.
Bye,
Good night, sir.
Bye,
Have a great weekend.
You too. You too.
Bye, sir.
Bye-bye, dearest.